Okay. Um, now I'm back to the script. Great. Let's get started. Your first task will be, did I ask you to share your screen? I think,
There we go.
I think I should ask you, even with the instructions. And later, I'll probably find the part where it does, and then I'll be embarrassed. Okay, your first task will be converting an implementation of the tree data structure, or some people call it trie, from Java to Python, and you'll do this one without the AI support. Your second task will be converting an implementation of the priority queue data structure from Java to Python, and you will do that one with the AI support. We'll also take a break between the two tasks because this session will take about 2 hours. First, let me tell you a bit more about this code translation task. The task is to produce a complete and working Python translation within 30 minutes. By complete, I mean that all of the functionality and documentation of the Java code should be translated. And by working, I mean that the Python code should be tested for correctness. As I mentioned earlier, there's more work to do to accomplish an absolutely perfect translation than what can be done within 30 minutes. So really, I'm asking you to just do as much as you can in the time that you have. But there may be trade-offs in how you spend your time, such as whether you choose to translate all of the functionality first or to translate a portion of it while testing it to make sure that it works. How you navigate this trade-off is completely up to you. No right answers, no wrong answers. There are a few other things I should mention about this task. You'll be using an online version of the VS Code editor in this study, which has a few minor differences from the desktop app. In general, all of the menu commands and keystrokes are available and should just work, but please do let me know if you encounter any difficulties. I won't be able to answer any technical questions about the code or what it's supposed to do, but I can tell you that the Java implementation is correct. When you make the translation, please try to preserve the naming of class and method names, but we are less concerned with how you name the variables. You can also use whatever resources you feel would be helpful, such as searching the web or Stack Overflow or running any of the code, since we've installed Java and Python in the editor. I'll give you a 5-minute warning when the time is almost up so you know when to start wrapping up your work. We also ask, as you work on the tasks, you think out loud and tell us about what you're thinking and what you're doing. This really helps us to understand how you approach the task and what you're thinking about as you do it. If you're quiet, I'll remind you to keep thinking out loud. Do you have any questions before we get started?
Nope, just one thing. I would like to plug in my laptop so I don't accidentally die on you.
What a good idea. Let's do that.
I'll do that right now.
Thank you.
All right, business.
Okay. I think the friendly reminders here I think are for me and not for you, so I am just reading through them to make sure I do this right. Um, okay, I think I got it. So back to the instructions. We're now in task 1. In this task, you'll translate the tree or trie data structure from Java to Python, and you'll do this without AI support. Please put your solution in the tree or trie.py file. And I need to give you a link to the code editor so you can do this. And I'm going to paste that into the meeting chat. I have now pasted it. So if you would go to that link, then we can begin. And let's see, is it possible for you to make the font just a little bit bigger to zoom in one level?
Yes, let's see here.
Perfect, thank you. That is great. Okay, I will now start the timer, and we have 30 minutes to do this task, and please think out loud as you do it.
Okay. My Python is slightly rusty, so I'm definitely going to be using the web option here to look up some syntactic things. But let's take a look at the code first. Okay. So implements a tree object for sorting and retrieval of strings. Okay, so we have a class with a node subclass, and we have a root. Every node has a hash map from character to itself, and that's the children. Okay, and an isWord boolean. Okay. The isWord is private, and it seems to always be false as far as I can tell. And it's only set via the setter. Okay. Just gonna quickly scroll down to see what the tests look like, or if there is any tests. It's the main method. There is no main, so there are no tests here. Okay. Okay, so we can find things, insert things, delete, recursive delete method. Okay. It's got an enumerator to traverse things and a merge. Merge two trees into one. Okay. So the constructor just constructs a single node, and I presume we need to add things after. The only mutator that I can see is, well, the deletion, but to add things, you can only insert a word. Okay, so let's start with that. So let's pretend we created a new tree. So we only have a root node. So what it does is, yes, given a word, it traverses each character of the input. And then from the root node, it seems to, okay, so if this letter, so for each letter of the word, if it's not in the tree already, it would insert a new node into the root. So let's see, get children, and then compute if it's absent. So if the current character of the input word is not present in the children array, then it creates a new tree from the given character, and then sets that to the current. Okay. And then at the end, it sets that the word, the isWord, to true. Okay. Just gonna read some of the comments that have been written already. It basically builds a tree of nodes where each node represents a character in a string that has been stored in the tree. A stored string is represented by a path in the tree from the root to a node marked as an end of word node. Okay, so a stored string is represented by a path in the tree from the root to a node marked as an end of word node. Okay. The tree node class used by the tree class to store individual nodes in the tree. Each node represents a point in the stored string and has a set of children nodes which represent the next characters in the string, indexed by the character that leads to that node. Isword flag set to true means that this is the end of some string stored in the tree. Okay. Okay. I clearly need to brush up on trees, but I think we can start some sort of translation at least. Let's get the skeleton working. Okay. Let's see what is the best way here. Trying to split these up. Whatever, we can just work like this. Okay, time to brush up on some Python. Python classes. All right. So inside of here, we have a tree node. Probably need a constructor to construct the root. So we need an init. And from the Java code, the root is just a new tree node. Okay. So let's get the tree node class now working. Okay, so the tree node just contains a hash map from a character to itself. Oops. So it needs a constructor. No arguments for this. So it's got children and an isword. Okay. So children. Then we need a hash map from a character to tree node to itself. Okay, and then an is. Which is false. Okay, so Python hash map. Which is just a dictionary. Okay. Right. Okay, so I guess a dictionary would be okay. Just initialize it to an empty dictionary for now. Okay, so this one has get children. It returns a dictionary. Okay. Oops. Yeah, so it has an is end of word. So you just getters and setters. Okay. Um, get children is end of word and set end of word. I copy that right. And now setter. Uh, is word is end of word. Sure, we'll just keep the names the same. Okay. So that's our tree node for now. I'm not 100% sure about the hash map, but we'll get back to that. Okay, so now we have a constructor, we have a private root node, which is just a single tree node. That's fine. And we have an insert method, which accepts a string. So insert which accepts a string, which is a word. Okay. So we get the current node and then we loop for each character in the word. Okay. So current is equal to the root for, so let's see, Python looping through string characters. Stack Overflow to the rescue. All right. So for each character in the string. All right. So for each, oops. So for, I'll just mimic the same L. So for each letter, I guess letter in the word, we want to get the current children and then compute if it's absent. I have not used this before. Okay. So for each letter in the word, so we want to check if the current children has this inside of the dictionary, I guess. Okay. I'm guessing it checks if it has it as a if it has it as a key. So let's see. So I guess we want Python dictionary search for key. Okay, seems simple enough. So I guess we do if the letter is in the current get children. So if this letter is, if the letter is, I'm not sure what this does exactly, so we're going to look it up. Okay. So this method accepts a key and a remapping function. This method returns the current or existing computed value associated with a specific key, or null if mapping returns null. Okay. So compute if absent. So we print the hash map, okay, and then provide value for new key which is absent using compute if absent method. So key 5 is not present. So I guess it just inserts key 5 into the hash map if it's not already there. And if it is already there, I guess it returns the existing one. Okay. So if this is already in there, it returns the value of that dictionary entry. And if it's not, we construct a new tree node. Okay, let's do that. So if the current letter is in the children, then current is equal to current. It's probably not the most efficient way to do this. Then we need to index by that letter. Okay, and if it's not, current is going to be a tree node. It's going to be a new tree node. Okay. Oh, current dot. So get the children, and then so we construct a new tree node for this letter. I guess we just assign it the current. Okay, I think that does that. Insert, and then at the very end, we set the is end word. Set to true. Okay. I guess that's insert. Okay, now we have a find. Okay, so given a word, we iterate through all the characters, find the tree node to the corresponding character. Okay, I'm just going to translate this word for word, pretty much. So find a word. Don't know, it's not letting me. Ah, there we go. That's what I wanted to do earlier. Okay. So current is equal to the root for I guess for each character in the word, node is current get children I guess we test if this character exists, then current is the node. Otherwise, return false. Right, capitals. Okay, that looks correct. And at the very end, we return current is end of word. Okay, I think that does find. Delete. Delete root word 0. This is pretty easy. I'm not even trying to understand what this one is doing. Just literally translating without even thinking at this point. Okay. Screen is a bit too small for this one. Okay, so how do we delete a node? Recursive delete method. Okay. Starting from a current node, you have a string to be deleted and the current depth that we've descended. Returns true if we deleted something, false if nothing was found. Okay. Current word index. So if index is length of the word, then if current is end of word, so if we're not the end of the word, we return false. Otherwise, we set end of word to false. And then we return current children if it's empty or not. Okay, time to Google again. Forget how to check if a dictionary is empty. So Python dict is empty. Apparently you just convert it to a Boolean. Empty dictionary is evaluated to false. Okay, so okay, that takes care of the first part. Otherwise, we get the character at the index. We get the character at the index, and then construct a node is the dictionary value. So again,
and it's 5 minutes to go before the end of this task.
okay. So if the current children if it exists, I guess if it doesn't exist. If it doesn't exist, then we want to return false. Otherwise, node is probably a much better way of doing that. That's okay, we'll ignore that. Then should delete current node. Looks like there's the recursive call. Right. Node is end of word. Okay, so that's our Boolean, and then if we should do that, then we want to remove a dictionary entry. I think it's the del, but I forget. Python dict remove key. Pop. Okay. To delete a key that is guaranteed to exist. Let's see, is it guaranteed to exist here? It is, otherwise we would have returned false already. So we do want to do that. So delete dictionary key. Okay. So current, get the children, and then get the character, and then delete it. And then we want to return if the current children dictionary is empty or not. Okay. Otherwise, we return false. Okay. Haven't followed the logic, but that is just the literal translation. Okay. Enumerator. Two enumerators and a merge. Okay. Enumerates the strings stored in the tree. Not too familiar with Python enumerators, I mostly use it for scripting. An iterable and a start. This doesn't look like support for enumerations. No, these are just enums. I don't think this is what we want. Python iterators. That's probably what we want. Okay.
Okay, thank you. We ran out of time,
Okay.
as was intentional, so no criticism of you. But thank you very much. That was fascinating and really, really helpful to us. Let's go on to the next part. Um, sorry, I need to make one single notation first. Now I did that. Um, I have another link for you. This should take you to a questionnaire that we would like you to fill out. And there it
Okay.
is in the chat. And as you fill out the questionnaire, oh, you are P21. You like participant 21. Thank you.
So
And
this was
this is
node,
no, I
right?
can, right, exactly right. And tree.
A tree.
Super.
Okay. Just gonna close the chat. Okay, mentally demanding was a task. Okay. I mean, it was just translation, so I was rusty on Python, so it did require looking up stuff and digging back into my brain. So somewhere mid-ground, let's say a 10. How hurried or rushed was the pace of the task? Okay, so definitely much more rushed as soon as I heard that 5 minute warning. I thought there was not enough time to understand what all of the code was doing. So after the first 5 or so minutes, I just started blindly translating things without even understanding. So I'd say it was probably more hurried than not, but not like extremely hurried. So let's say 14. Uh, how successful were you? Well, I did not complete it, but I guess that was the intention. I didn't fail it either. I think I came 2/3 through, not even. So maybe a 13 or 14. Maybe a 12 is a reasonable number there. Uh, How hard did you have to work to accomplish your level of performance? Okay. Typically don't code either Java or Python in my day-to-day. Um, so I had to work reasonably hard, but not extremely. I mean, it's not overly complicated, so maybe a 7 or an 8, maybe an 8. How insecure, discouraged, irritated, stressed, or annoyed were you? Not very high, but definitely I was irritated that it didn't come as easy. Maybe a 12. Please describe your overall approach for how you worked on this task and how you allocated your time across different activities. Okay. Uh, First, I wanted to understand what the code was doing, but due to the time constraints, that was not feasible. Task at hand was language translation task. So I stopped trying to understand the code fairly quickly and just mindlessly delve into the translation task. Overall approach was to simply open both implementations side by side and translate method by method, looking up Python concepts I was rusty on via Google during my translation. Okay, to what extent do you feel you understand how the Java implementation of the data structure works? Very little. Very little to somewhat. I'd probably say very little. It's about 160 lines of code and probably parsed in the first 5 minutes, pretty much all of it, and didn't get to kind of build my mental model of how the thing works because it was just translation. Time constraints plus this was only language translation. So it is kind of straightforward as long as one is familiar with both languages, which I was not. Examples of use or visual thumbprint of the data structure would have helped with tests. Okay. Is there any other feedback you'd like to share us about the experience of this task? Hmm. Other thoughts? Having tests would have helped to understand the code better. I don't know, the task at hand was fairly straightforward. For someone that has to look up syntax for certain language concepts, the time allotment was not enough. Otherwise, I think a seasoned this fairly quickly. Okay, I think that's it.
Thank you very much. Let's take a 5-minute break.
Sure.
I'll leave the recorder running, so just so you know that if you say anything in the microphone, it's going to get picked up. But I'm going to walk away from the laptop though for 5 minutes also and take my own break. See you soon. Thank you again. Oh, I forgot to say, please save your code.
Save it.
I think the editor probably has been saving it, but there should be a hamburger menu someplace which might have a save in it, possibly in the upper right.
All right. Sorry, WebEx is getting in the way.
Maybe not there. I'm sorry that I don't actually know how to do the save. I'm embarrassed. I don't do your kind of work for a living.
I tried Command S. That should typically do it.
Yeah, that should do it. Great. Thank you.
Yep.
Super. All right. See you in 5 minutes. Thanks a lot.
Yep. Bye. All right, I'm back.
Great. Thank you again. I need to get back to my script and read you the next part. So we're now on task 2. In this task, you'll translate the priority queue data structure from Java to Python with the help of an AI code translation system. This system is able to automatically translate code from Java to Python, but it's not a perfect system, so the translated code may contain errors in it. We use this system ahead of time to create a Python translation for you, which you'll see when you open the editor. How you use this translation to help you complete the task is entirely up to you. For this task, please put your solution. Yes, whoops. Learn to speak, Michael. For this task, please put your solution in the priority queue.py file. And now I need to transfer the link to you, which I am slowly doing. There it is.
Okay.
Okay. Ready to go?
Yep.
I will start the timer. Thank you.
All right, just gonna close all the tabs from the previous exercise. And this is saved, so I'll close that too. Okay. All right. I guess learning from the previous one, we need to do a quick scan of the code. All right, priority queue using an array-based implementation of a binary heap. This class can be parameterized for any element class that supports the comparable interface on itself. Okay. So extends comparable on itself. Okay. Priority queue allows one to store comparable elements and remove them in order defined by the comparator. This implementation will remove the highest priority items first. Insertion and removal are both login operations in terms of the number of items in the queue. Okay. So it uses an array list as an implementation. Okay. So we want our, let's see, how do we structure this? Okay. Much more concise on the Python side. Okay, so we are able to use the AI assisted translation into implementing our own. Okay. So first thoughts, at least to me, just doing a skim of the code. So let's just pick one method that seems reasonably easy to understand. Remove. So if the size is 0, you don't do anything. You can't remove if the queue is empty. Otherwise, swap the last item in for the first. Get the first one. So it just seems a bunch of function calls or method calls. So my first thought is, let's check out the AI translation of this and see if it got the remove method correct. And if it did, that gives me reasonable confidence that it can translate some pretty simple methods at least. So remove, okay. So if the length of the current heap is 0, it returns nothing. Seems reasonable. Otherwise, it gets the heap index. I don't know what the type of heap is yet, but okay. Extracts the element at the index. So that seems incorrect because this one extracts the 0th element. Then it sets the 0th element to the index. It removes the highest it removes the index from the array list and then calls heapify. So this one starts at 0 and it goes to a certain size. This doesn't look like the same call. Okay, seem to have done a reasonable implementation. I think I need to understand what the heap type is. So here it's an array list of whatever type, and here's okay, it's just an array. Okay, so it seemed to be doing a reasonable job. I haven't gone through the rest of them, but my initial thought is I'll just copy the entire implementation and then go through the translation of the Java code and just see if it's correct or not. So I will do that. And I think copied. Let's try that again. All right, here we go. Okay, so priority queue. We have a constructor that constructs a new array list. So in Python, that's just going to be an array. We have an insertion method that inserts an item. That looks correct. So it gets the size. The index is the size of the current heap. Whereas here it's the index of the item. That doesn't seem correct. That doesn't seem correct, so I'll just change that. So it's going to be the length of the heap. Okay, and then it adds the item, the current item to the heap. Okay. This inserts it. This appends Python array append. Oops. So we just want to append the item instead of inserting it. Okay, and then while the current index is greater than 0. Okay. Right. Seems fine. We find the parent index. That looks correct as well. Integer division, that's correct. So we get the so the parent is not the end. It's parent index, and then while it's so you compare the parent to the item, okay, and then we insert it. Yep, that looks correct, and otherwise we insert index into parent. That looks correct too. That looks correct. Otherwise we break. Okay, and the insert is done. Remove. Okay. So if the length of the heap is 0, then we want to return nothing. Okay. Otherwise, the index is Yeah, it seems to get these incorrect. Anything to do with size seems to be problematic. So okay. So now we want to get the first element, and then we want to set the first element to the last, the indexed element. Then we want to remove so Python, that looks incorrect. Python array remove index. So just delete. So we want to do delete heap index. And then we call heapify with, this looks incorrect. So let's see where heapify is. Heapify needs an index and a size. So index size. Okay. And then you return the element. All right, that looks correct. The size, it just gets the length of the heap. That's fine. Peak returns really interesting code here. The if and the else are the same, so that's not right. Peak returns the 0th element, so the returns the next element to be returned by remove without removing it from the priority queue. Highest priority element in the priority queue. I have no idea, at least in the Java implementation, what happens if the heap is empty. It'll probably throw an exception, so I guess we'll just do the same thing in Python. So we want to return first element. Okay. I'm sure whatever peak is called is probably checked if it's empty or not. I forget if Python forget if you check if it's empty that way. You don't. I guess you could check if the length is 0 or just apply the not. So we want to do is empty is that. Enumerate. Okay. So saved heap is a copy of the current heap. What is copy? Let's just see if that's correct. Deep copy Python. Shallow and deep copies. It forgot to import copy. It probably knows about cloning, but it doesn't know that it needs to import. So let's add that up there. Okay, so now we should be able to copy things. Okay, that's fine. Result is just a new list. While we are not empty, so there's no empty in Python, it's just not. I don't like this. We're going to change that. So while it is not empty, so while, maybe we'll just check the length here too. I guess you could also do not, but well, it's not 0. I'm going to call remove, and then append to the results the thing you removed. Okay, that's fine. Now heap is the saved heap. Yep, that's fine. And then you return the results. Uh, for x in results if x priority is 0. Don't know what it did here. Priority queue order. I don't know what's happening here. It should just be the results. Okay, add all. So given a collection, we loop through all the elements and we just insert all the elements in there. Yep, and then it returns, doesn't return anything. So that should also not return anything. So that's fine. Heapify, private method. Okay, an index and a size. Did a good job of translating the documentation from the Java docs. Okay, so if the heap is, it's missing a self here. So if, well, it's checking for the size. So I don't know why it's looking for the heap. Okay, so if size is greater than 0, so find the left and right indices. That's fine. The parent is you index by the index. Okay, the max index is the index. And now you compare. So if the left is less than the size and the heap left index, you compare that to the parent. So, okay, if it's greater than 0, so compare to, that compares this with that, and if this is greater than that, it returns greater than 0, so that looks okay too. And the max index is the left index. And then similarly for the right. So the size is incorrect, and you compare the right index to the left index. No, you compare the right index to the value at the left index. So this is incorrect. So that's what we want. And the max index is the right index. Okay, and then we check if the max index is not equal to the index. Otherwise, swap them and recurse. Okay, so then set the index to the max index, that's fine. And then set the max index to the parent, and then, oh, I don't know what this is calling, but it's definitely not heapify. And then we need to use the max index and size. size. Okay, I think that about does it. Let's see, just if we missed anything. Constructor, inserts the size. Just use my finger to look at the lines of code while comparing. We get the size, we append it, we check if it's greater than 0, calculate the parent index, get the parent, check if it's less than the current item. If it is, we insert, well, no, we set. This looks incorrect, so we're just going to change that quickly. So we're not inserting anything. We're just saying at the parent index, we're setting this to the item. And the index, we're setting that to the parent. Okay, and assigns index to the parent. Otherwise, it breaks, and that's it. Okay, remove. If the length of the heap is 0, return nothing, none. Otherwise, index is size -1. The element is the first element. And then set the first element to the element at index. Then remove the index. Okay, and then call heapify with 0 and the length of the heap. So that's incorrect. Missed that in the first pass. Self size is just the length of the heap. Peeking gets us the first element, is empty, returns if there's anything in the array. Enumerate creates a copy of the current heap. It's our saved heap. Then creates a result array. And then while the length of the current heap is not 0, it removes from the current heap and adds it to the results, and then resets the current heap. Okay, looks correct. I don't, okay. That looks correct. Add all just enumerates through the collection and then inserts each element. That's correct too. And then the heapify. So compares, checks if the size is greater than 0, and calculates the left and right index. Yep, that's right. Extracts the parent is the current index in the heap. Sets the max index to the index. Does a left comparison against size, and extracts the left index from the heap and compares that to the parent. And if that's true, we set the max index to the left. For the right, we check against size. And if the heap at the right index is greater than the heap at the left index, then we set the max index to the right index. Okay, that's correct. And finally, if the max index is not the current index, we want to swap them. So we set the heap at the current index to the max index, and then we set them, we assign the parent to the max index. Then we call recursively heapify the max index and size. Yep, that's correct. I'm going to save this and save that. Okay, I would say I'm complete. I think you're on mute.
Yes, I am. You're right. Um, I think I am allowed then to say if your coding is complete, then you could test it if you want, since we still have some time.
Okay,
Thank you.
so let's see. I don't know if there's any tests here. I don't see any tests. Are there supposed to be tests?
I am not supposed to answer that question. I'm sorry.
Okay. Um, oh, might as well give this a shot. Okay, nothing happens. Okay. So, let's see. Priority queue examples. Um, let's see. Sure. Let's just find out if we insert. Uh, okay. So elements in the priority queue are, okay, so let's use this as an example. So it inserts a bunch of numbers and iterates through everything and prints. It deletes the element at index 2, and then it prints everything again. So
I
hopefully,
should say this is your 5-minute warning.
okay. So let's try to do this quick. Okay. So our code seems to compile, so nothing is failing. I'm just gonna, oh, it's Python. Um, so let's see. PQ is equal to priority queue. Insert, we can just probably copy paste. I'm going to assume that this website has correct implementation. So let's see here. So we insert a bunch of numbers, and then it prints all the numbers in the heap. Let me just make sure that's correct. Okay. Or the priority queue object is not iterable. Okay. So something went wrong. Let's check it out. Space in the editor. Oops, I'm looking at the Java. Okay. Not 100% familiar with Python iterators, but I'm guessing it needs to implement some sort of APIs for it to be able to iterate. I don't see any accessors other than the enumerator. So Python iterator, I guess custom iterator. How to make an iterator in Python. This doesn't seem like what we want, right? So you can iterate, then it has a next. Okay, so this translation will probably not work for from Python to Java. So the enumerate, I guess the enumerate returns a list. So let's just do this. L is equal to PQ dot enumerate, and then we iterate through L. So let's run that. Okay, 21, 20, 19. Whoops, I lost my other page now. Huh. So 21, 19, 20, 18. So it definitely did not return the same thing, at least initially. Okay, so something went wrong, but let's just continue on. So next thing it did was um, it deleted the element whose index is 2. So where's our remove? I don't think we have the ability to delete things at an index, but we
I
can remove.
apologize for stopping you in mid-task, but we just ran out of time,
Okay.
which again was by design. You weren't supposed to be able to finish this, so but you were getting real close. Okay, if you would do Control S again to save the state of that code, I will return to the script and continue reading.
All right, all saved.
Okay. Um, Now we have another post-task questionnaire. So there'll be this one, and then there'll be the comparative one after that, and then we'll really be done. And so I am opening the chat and posting the next survey link there. Thank you very much again for doing this. You're still P21. This was the AI, and this was the priority queue. Great, thank you. I know you knew all of that. I'm just confirming.
Yeah, of course.
Now I'll be quiet.
Okay, how mentally demanding was the task? It was, well, I learned from the previous one, from the time constraint, I shouldn't try to understand the full implementation since it's just a translation. So, and the fact that I had pretty much all the syntactic things out of the way, helped quite a lot. So I already pretty much had an implementation. I just needed to read the Java, read the Python, and make sure they match what I would have done as a translation. So it was probably less demanding, not very low, but probably like a 4 or 5 maybe. Um, how hurried or rushed was the pace of the task? Much less hurried because I had a baseline to work off of. Um, and I felt I was getting pretty close to the end. Just a little bit more searching to find out, remove some items and see if we got the extracted the right thing from the queue. So probably like a 6 maybe. It was definitely not as rushed. How successful you were in accomplishing what you were asked to do? Well, the task at hand was to translate, which we did, but we don't know if it was a correct translation or not, assuming that the Java code was correct to begin with. So we didn't get through testing our code, so I can't say it was perfect. It was definitely not a failure. We did succeed in translating everything, and we got to printing some items. I don't know if they were correct or not, but the code compiled and seemed to have worked. We were able to insert. I didn't delete anything, but we were able to print as well. So it wasn't perfect. It was not a failure. again, between 4 or 5. Let's just go with a 5, assuming the Java code was correct, and we probably had some bugs because we haven't tested. How hard did you have to work to accomplish your level of performance? Definitely not as high. Not too, I mean, I don't code Python in my day-to-day. So getting all the syntactic errors out of the way and looking up some of the easy things like getting the length of things or checking if the size or whatever APIs that I would normally have to look up. I didn't really have to do that anymore because I had a baseline to work off of. But I am pretty proficient at reading the code. So I did not have to work very hard at all, I think. Maybe a 6 here would be appropriate. How insecure, discouraged, irritated, stressed, or annoyed were? Much less so than the last problem, I would say. Yeah, I don't know, that was kind of straightforward. I even had time to go over the implementation twice. Second time caught some things I didn't catch on the first pass. Could have probably went over it again even, and then got on to some testing. So I don't think I was very stressed at all. 5 seems reasonable. Maybe even a 4. Okay, please describe your overall approach for how you worked on this task and how you allocated your time across different activities. Having a baseline was a great help for the translation task. My main time sinks were looking up syntax and Python versions of the Java APIs. Having the baseline there, even if incorrect, they implemented saved quite a bit of time skimming the translated implementation. At the start, gave me a reasonable confidence about the structure of the code. Yep, so skimming it at first, I kind of got confident that the structure of the code looked correct. I didn't have to copy over method and local variable names. And the structure was more or less identical in terms of control flow. So I was reasonably confident that all I had to do was compare the implementations line by line to ensure things were translated correctly. Okay. To what extent do you feel you understand how the Java implementation of the data structure works? Definitely not at all. I guess the task at hand was to translate, which had pretty much already been done. So I was literally just looking at the code without even thinking about it and translating Python to Java. Definitely much less thought into how this thing actually works than the previous exercise, I would say, which probably helped get through it much faster. But I would say I definitely don't understand what the Java code was doing or if it was even correct or not. So I'll just write that here. All right. Since I had baseline to work of, spent a little time actually understanding what was being translated Java to Python. Um, um, the task was to just translate code. So that is what I did without thinking too much about whether what I was translating was functionally correct or not, or whether code even made sense. Only when we got to the testing part did I stop to think about priority queue even works, or what the expected output enumerating would be. Okay. How would you characterize the quality of the provided translation? It was, well, I guess quality I would quantify as actually working, which this was definitely not. I'm not even sure if it would have compiled and ran with the original implementation, but so it was, I wouldn't say it was good. It was definitely acceptable. So probably somewhere between these two. I'm leaning more towards the acceptable option. Um, I'm not sure if the code would have even compiled, although hard to tell. Python, it's nothing. Since nothing is compiled ahead of time. However, some of the even easier method translations were incorrect with subtle bugs that may be hard to spot. Yeah, the fact that I had to go over, well, I was reasonably comfortable with the first pass of the code, but then when I went through this, I was reasonably comfortable with my fixed translation after the first pass through the code. But on a second pass, I realized there were several mistakes which I had missed, some of them a little subtle. So in terms of introducing bugs, AI versus non-AI, I think less bugs may have been introduced if the translation was done by hand. Okay, although that would have taken much longer. How do you qualify? How did you qualify the translation match your expectation of what could be produced by an AI system? I thought it was better, but not much better. I wasn't, I didn't think that would have been the translation. I would have thought it would get some sort of skeleton correct, but not not what was provided. That was quite helpful. Um, to what extent did you feel the provided translations were useful? They were definitely very useful. The provided translations, they had somewhat of errors. Helped you complete the task? It definitely did. Helped you understand the original Java code? Not at all. Taught you something new about Python? A little, but I see how it could have. Um, did you feel, well, I want to put somewhat, I don't think I've ever used deep copy. So that was nice that I was able to translate that. Did you feel the provided translations made your work in this task difficult or easy? Um, I think it made it pretty easy. Okay. Did you feel that the provided translations made your work slow or fast? It was quite a bit faster. I don't think I would have completed that um, without the translation. Did you feel that the provided translations made your work of this task of worst versus best quality? Major work in this cast of the worst or of the best quality. Okay. So I think I mentioned this previously. They definitely help with the translation, but I think if there was unit tests or things like that that we could test, it might make me feel more confident, but I wasn't really thinking about what exactly am I translating. Um, so I would say if I had to hand code it, it would be more bug-free, and would have had to have thought about what is it exactly that I'm doing here, um, but not by much. I guess when it's translated like that, we could have easily, for example, we're calculating the left and right indices, maybe just put left index where there was supposed to be a right index. And I would have just skimmed over that, assuming it was correct without even thinking about it. Whereas if I was translating it by hand, I would have definitely thought about what is it I'm doing here. Um, what did you find most useful about the provided translations? The skeleton of the translation matched quite closely what was provided in the Java implementation, making a method by method comparison trivial. It also did a good job with translating APIs such as objects, array list to Python list, um, iteration of elements in lists, loops, etc. And of course, oh, I think I already mentioned the structural implementation of each method. And the least useful was the small, subtle problems in trivial translations. I think there were several cases where it was supposed to translate simple things like size -1, but it translated it to size or something bogus um, for an untrained eye, which is skimming over the code. Those differences may be very hard to spot. To even on my second pass through the code, I was still noticing errors. Were enough translations provided for you? Yeah, that was fine. What additional information could we have provided alongside the translation to make them more useful to you? Testing would have been great. For example, unit tests or any or any code that can run for that matter. What additional information would you expect as part of an explanation of how the translation was made? What additional information would you expect as part of an explanation of how the translation was made? I guess thinking outside the box, or I guess this is a question on how the AI could be improved to show something about the translation and how it was made, perhaps for additional information, it would have been helpful to hover over a piece of code, so translated code, and display the original piece of translated, I guess, Python code, and display the original Java implementation. I assume the translator does this by statements, so it should be possible. This would make it easier to compare statements translated between the languages and would help in identifying small subtle bugs in the translation. Okay. For the following work conditions, to what extent would AI-supported code translation be helpful on normal working conditions? I don't think we often have to translate code, at least in my line of work. So I would guess normal working conditions would be, I guess, slightly helpful if we had to do it. Under time pressure, well, I would say it would be helpful, though I'm not quite convinced on the correctness piece still. When working alone, okay, it would be helpful. When working on code that only I would use, okay, if it's only I would use, I think it would be very helpful because chances are, even if you get something wrong, it might not be mission critical. Working on code that my team members or other people would use, I think I would still revert to slightly helpful. I don't think it's not helpful in any case. When working in a small team, it would be okay. In larger teams, it starts more things could go unnoticed. When working on experimental or prototype code, okay, probably I would even say extremely helpful. If we're just working on quick prototypes, see something will work, or I don't know, Python is too slow, we need to translate to C++ or something, need to get something out quick to see if it's going to be fast or feasible. Yeah, I'm working on production code. I think this is where I might draw the line. It's leaning towards here. I wish there was a button in between. I would say it's still helpful, but I wish there was a button in between. For which situations would AI-supported code translation be appropriate? When code is used for mission-critical application, no. There needs to be a human thinking about this at all times. When the code's correctness is important, I would say no. I was not thinking pretty much at all when doing that second exercise. When the code's runtime performance is important. It might be appropriate. Translating between languages word for word is usually not going to get you the best performance. Like there's probably some things that are done much faster in certain ways in different languages. When there is a large code base to translate, I would think it would be very, maybe even extremely appropriate in this case. Well, I guess that still depends. I would say very. I guess in the end, we would want to get correctness, but I assume if we're translating a whole bunch of code, we'll have tests, which test all this stuff. So getting large swaths of code translated really quickly and then testing them with tests is probably the right way to go. When the original code is written in a language which I'm unfamiliar, I think extremely appropriate. I'm not too familiar with Python. I pretty much only use it for scripting. So dealing with classes and objects and things in Python, I'm not too familiar with. So having a skeleton helped quite a lot. And when the code needs to be translated to a language which I am, when code is written in a language which I'm familiar, I think in both cases, either written or translated to. I think it would both be extremely helpful. How useful would each of these kinds of AI models be for, I want to change this. If I don't understand the original implementation, but I understand the translated, I guess we're going backwards. So pretend I don't understand Java and it translated me that Java code into Python, and I'm looking at the Python code trying to understand what the Java code is doing. But if the Python code is already wrong, then I can't really tell too much about the Java code, but it would still be helpful. And how useful would each kind of task, which kinds of AI models be for real code translation? A model that requires you to fix one problem per that'll be extremely useful. Even 10,000 lines. Just trying to kind of equate that to projects we work on, which are about 1.5 million lines. So this would be about 150 bugs. It would probably still be useful if I had to translate that much code. 1 in every 1,000. Well, this is just going to be a sliding line now. Even 1,000 lines of code is still a lot of code. 100 lines though, yeah. Okay, 10 lines is, yeah. Oh, yeah. It's probably the expected output. Okay, any other feedback that we'd like to share about the experience of this task? Yeah, I don't know, very interesting. Definitely had thoughts on how the tooling could be, for example, hovering over translated code and displaying the original. I could definitely see the benefit of having a translation in the second exercise. But the number of bugs I had to fix, I felt was quite a lot higher. I don't think I had to do a second pass on the tree implementation.
Great, thank you. There's one more, I think, relatively brief survey to do, and if you have a 3 o'clock, or if the 2 hours have a hard stop at the end of them, then we should go quickly because there's only 5 minutes left. I have more time if you do.
Yeah, I do as well.
Great.
I want to make sure I
Thank
provide
you
some
for
good.
being so thorough with this. This is wonderful, really.
Yeah, I was hoping to provide some good info. Okay, how would you compare your experience working on the translation task um, with AI? Felt felt much easier if the end result was to simply translate code into something that compiles. On the other hand, if there were unit tests present, I would not, I would feel more confident in the in translation, given the subtle problems that AI translation introduced. Although I think the translation plus debugging of tests would have taken shorter amount of time with the AI. Okay, so if I had to translate and it was a bunch of tests and we had to get them all passing, I believe I would spend more time debugging with the AI than I would with the hand translation, but I would spend less time actually doing the translation. So more time debugging versus more time translating. But I think overall, if we had to do translate and debug, I think it would take less time with the AI. Beyond code translation, what kind of AI support would you desire for writing or working with code? I guess this is kind of out of the box question. Generation of corner case unit tests. Maybe deduction of infinite loops or unreachable code. Generation of documentation based on the implementations. That's all I can think of for now. Okay. No. Probably over a year ago. Perl to Java translation. which parses XML. So as per to Java, it parsed an XML document that described a set of tests which run on different platforms and different Java versions with different options, and output a series of makefiles which involve tests. We wanted to remove the Perl dependency from our CI because of lack of proper support on various platforms that we run on. Okay. I think it was about 1,500 lines. Would you like to participate? Sure. Ah, 1 minute over time.
Wow, you're amazing. Thank you. Thank you so much. Um, I'm going to return to the script in case you want to talk further, but it is 3 o'clock, and if you've had enough, we can just stop. It's up to you.
Is there anything else to mention?
Just a set of debrief points. So I'll rattle them off quickly, and we can talk in detail if you're interested.
Sure, yeah.
People are making lots of AI models to assist with code, translation, as you saw here. We did an experiment earlier about generating documentation in Jupyter notebooks. Um, so going from code to Markdown. And of course, then the converse of that, convert natural language into code. So people are working on all of these things, and I think they're all works in progress. We certainly found, in the case of the documentation study, that about almost half the time people just said it was fine, and another almost half the time they worked with it. I think it was only 14% of the time did they actually rewrite the documentation from scratch. So mostly it, as in the case of skeletons, as you pointed out in your work in this experiment, having something was better than having nothing in most of the cases, but still. So works in progress. Um, what we don't know from all of that work, except for really the beginning sets of experiments that our group are doing, is whether the models are actually useful for software engineers. And so, there's all this, how do I say, really attractive theoretical problems that people are trying to solve, and then are they any good? So we're trying to find out if they're any good, because we're IBM and we build things for each other and for clients. Um, and so, so we're looking at things like, does it make the work easier or faster? You clearly saw some questions about that, and of course we'll be doing scoring like that. Um, and then sort of the overall question, we know it's possible to make a completely terrible translation. Um, how good does it have to be useful, or how bad does it have to be not useful? So eventually we'll be addressing that too. Um, so that's what we're up to in this project so far. It's a piece of experimental work within IBM Research. We get sort of a longer run on this than a lot of other projects do. So we're extremely lucky to be able to say why it's an interesting research question. It doesn't need to be a feature tomorrow. And so we're going at it as a research question, but always knowing that it needs to produce something useful at the end. That's the only points I wanted to make. Was there anything you wanted to say? Ask about, denounce us, anything?
Yeah, okay, yeah, very interesting. Uh, okay, I guess I have some thoughts
Yeah,
about
please.
possible applications in our line of work.
Mhm.
So I work on Java virtual machine, and one of the problems, well, one of the many problems that we encounter is our lack of testing. Um, so we've always had the idea of, for particularly the JIT compiler. So we're in a situation where I think AI could be applicable in a certain sense. So we have a just-in-time compiler which compiles Java methods. And in a perfect world, the execution output of a method in the interpreter, the JVM, and a JIT compiled method should be the same. Of course, we don't live in a perfect world. There's going to be bugs in the JIT compiler. So if we can assume that the interpreter always gives the correct output, if the output from the interpreter and the JIT compiler don't match, it probably means we have a JIT bug. And I've seen in the past from other researchers that generating code which compiles and runs, even though it does not make sense at all, seems to be possible. So we've always had the idea that what if we could just use an AI to just generate tests of random Java code that has various inputs and just produces some output, and then we could run it both in the interpreter and with a JIT compiler and kind of compare where we have an oracle. And that way we can just generate practically infinite amounts of tests and test various corner cases. Doesn't matter what the Java code is, what it does, as long as it compiles and it's able to run and it doesn't crash or anything like that, it would be useful for us.
Very interesting. Thank you. I'm going to pass that along to the team. We're beginning to think about what we would do in the second year of the project, and so wow, that's a really interesting one. Thank you.
Yeah. So, and if I don't know if you guys need more AI applications in, I guess, the runtime space, this could potentially be a collaboration. Or
Yeah, if the team gets excited, I will be back in touch, or one of us will be back in touch with you. Possibly
yeah, for
somebody
sure. Put my
who's
name
more
down
on
in
the.
email. Yep.
Yep, you did. It's great. Thank you so much, Philip. This is really great. I should say now back to the official voice. I'll tell our manager that we've completed this, and he will send you over 250 blue points. And thank you, thank you, thank you again.
Yep, you're welcome. It was a very interesting study. Thanks.
Great. Well, I'm glad it was interesting too. Have a lovely weekend.
Yeah, you too. Yeah.
Thanks. Bye bye.